Refraction of light. Before this, we have seen reflection of light. So for that, separate lecture is available in the playlist. You can see there. And here we are going to discuss about refraction of light, especially in case of rectangular glass slab. And then we'll try to understand what is the refractive index. So refractive index क्या है? Rarer medium, how it is important, denser medium, कैसे लाइट की प्रोपोगेशन को इफेक्ट करता है. Those things we are going to discuss inside this, and one more lecture will be there apart from this where we'll see refraction in a spherical mirror. So refraction, so in case of refraction we have two medium. Okay, so when light is going to travel from one medium to another medium, then refraction is going to take place. So again, this refraction phenomena is how going to affect in practical life. Suppose, for example, we have taken one lemon or any other substance. So generally, lemon we use regularly. If this lemon is kept in the tumbler, okay, and it is the transparent tumbler, it is filled with water, and we are going to keep the lemon in this. So finally, if you see from the outside, the lemon size will look bigger. What is the actual size inside the water glass? Okay, from outside it will look much bigger than the actual size. So why it is happening? Okay, so that how this refraction phenomena is going to affect the size of the lemon. So that bending of the light is going to take place. Another phenomena, if you see that, suppose we have again a glass, it has partially filled with water, okay, and here we'll have one pencil. So now you will feel that this portion of the pencil which is dipped inside the water, so how it is going to appear in the different way. It is going to be appear as a displace from the interface. So again, that is due to the refraction of the light. So again, some letters are going to appear to be raised when we are going to see through the glass slab. Okay, suppose some letters are written, suppose A, B, C, D, and if you are going to put the glass slab above this, and again you are going to observe. So finally, that it is will be appear raised one. So letters are going to appear raised one. Again, so different phenomena, different examples you can see in the practical life. So that are again depends upon the different medium to medium. So glass is the one different medium for the light, and we have water is the different. If you are going to keep the something in case of kerosene or turpentine, so that will have different phenomena. Okay. So this all depends upon the refractive index, that all we are going to discuss later. So when light is going to travel from obliquely from one medium to another, then direction of propagation of light in the second medium is going to change. That is called as the refraction of light. Suppose, for example, here we have interface. Okay, this is the medium 1 and this is going to be the medium 2. Now we are considering that this medium 1 is the optically rarer medium and this medium 2 is the optically denser medium. So rarer medium means here velocity of the light will be more, in denser medium velocity of light will be less. So this is the incident ray, okay. So finally this is the angle theta I, something we can call. Now when it is going to cross the interface, now second medium is the denser medium. So what will happen? This ray will bend towards the normal. This is the normal. Okay. So in denser medium, speed of the light is going to become less. तो ड्यू टू दैट क्या होगा, डेंसर मीडियम होने के कारण लाइट क्या होगा, नॉर्मल की ओर बेंड करेगा. सो दिस इज फेनोमेना. क्या हो रहा है, लाइट इज गोइंग टू पास फ्रॉम द कौन सा मीडियम, रेयर मीडियम टू डेंसर मीडियम. सिमिलरली if medium 1 is the denser, suppose for example, and here we have rarer medium. So this denser rarer is the optically denser, not basis upon the mass. Okay. So बाद में हम लोग देखेंगे how this rarer and denser medium is being differentiated on the basis of refractive index. Okay. यहाँ पर the light is going to come in this way. अब ये क्या है, denser medium is going to where? To the rarer medium. So this will move away from the normal. Okay. In case of rarer medium. So this angle is going to become large, where this angle is going to become small. In rarer to denser, this is the denser to rarer medium. So finally क्या हो रहा है, when light is going to travel एक मीडियम से दूसरे मीडियम में, तो उसका पाथ क्या हो रहा है, चेंज हो रहा है. So due to this, why path is going to change, this phenomena is called as the reflection of light. So एक मीडियम से दूसरे मीडियम में travel करना. And here we have some activities there. Now suppose for example, coin is placed in the empty ball or something we have taken. So how it is going to appear? Again, if you are going to put some water, after pouring some water in this ball, then what you are going to see that it is the slightly raised from the actual positions. So that is happening due to reflection of light. Okay, at the interface of the water and air, the direction of the light is going to change. That's why it's going to be appear slightly raised one, थोड़ा ऊपर उठा हुआ महसूस होता है. Now we have refraction through a rectangular glass slab. एक rectangular glass slab है. So slab मतलब इसका कुछ thickness. So first it will go from the if outside is the air, so from the air to glass, one interface. Again from glass to air will be the another interface. So this reflection is shown here with the help of diagram. So here if you'll observe, ABCD is going to represent the glass. Outside we have air. Again this side also we have air. So air is the rarer medium, optically rarer medium in compared to glass, and glass is the optically denser medium in compared to air, and air is the again rarer medium in compared to glass. So optically rarer medium is what is meaning? The speed of light will be more. Optically denser, the speed of light will be less. So now here one point is marked here, that is the O. On this we have normal N and dash. And EF is going to be the incident ray here that makes the angle I1 with the normal. Now, if you see that if wave is going to propagate without changing the path, so they have this dotted line. Okay, this dotted line will be the actual path. But क्या it will travel in the straight line? No. Glass क्या है? Denser medium. So denser medium. So क्या होगा? Ray will bend towards the normal. Okay, so that you are going to observe here. This is the R1. Okay, so this R1 is showing the here angle. So ray has bended towards the normal. This came towards the normal from the actual path, since glass is the denser medium. Again, inside the glass, it is going to travel as the straight line. Again, we have another interface here at point O dash. So here incident angle is the I2. Now this air outside, what we have? Air. So air is what? Rarer medium. So now what will happen? This ray after refraction will move away from the normal, or it will move towards the normal, or it will bend towards the normal. So what will happen here? It will move away from the normal. Okay, it is moving away. GH is moving away from the normal. So finally, if you're going to observe, so the actual incident ray, that is the EF, and this emerged ray, GH, both are going to be the parallel of each other. Okay, so that we are going to observe here through this refraction through the glass slab. So here two interfaces there. Okay, so both are where this is the air glass interface here, and at this position we have glass air interface. So two different interfaces going to occur. Here we have rarer to denser medium. Here we have denser to rarer medium. Okay. So that's why here shifting takes place in the both position. In the first one, it is moving towards the normal, bending towards the normal. In the second interface, it's moving away from the normal at point O dash. So this is the discussion about how this refraction of light takes place through the rectangular glass slab. So on the basis of this, we have important question. Sometimes maybe this question will be separate. One will be about refraction. One may be law of refraction. So refraction through the glass slab is the separate question, and laws of refraction is separate sometimes. So laws of reflection says that it is a refraction, not reflection. Be careful. Laws of refraction. So here also we have incident ray, refracted ray normal to the interface of two transparent medium at the point of incident lie in the same plane. Incident ray और क्या है reflect, that is refracted, not reflected, refracted ray और normal, ये तीनों क्या है एक ही plane में lie करता है. And again second is the ratio of angle of incidence. Okay, ratio of sine of angle of incidence and sine of angle of refraction is the constant. So this two ratio is always constant. So light for the given color and for the given medium, that for the pair of medium as well as color. So this law is also known as Snell's law of refraction, and this angle I, that incident angle, is going to lie between 0 to 90 degree. Okay, and I is the angle of incident, R is the angle of refraction. So finally sine I by sine R is the constant. It is called as the Snell's law. This is about the purely about the refraction. Now why this phenomena is going to occur, so that is going to depend on refractive index. What is the refractive index? Okay, that we are going to see. So in general, the speed of light in the vacuum is considered how much? 3 into 10 to power 8 meter per second. कितना है? 3 into 10 to power 8 meter per second. That you know from school days, right? From the, still you are in school, but from the lower class onwards, you are knowing this. So the refractive index is going to be the ratio of light in one medium to the ratio of light in another medium. So when we'll have this value of refractive index, you see that we are going to compare that air as the reference medium, since generally vacuum we are not able to get everywhere. So air will be taken as the reference medium, and another medium like glass, water will be the medium 2. And the reference medium, the velocity of light in the reference medium or speed of light in the reference medium will keep in the numerator, and the medium for which we are trying to find the refractive index, that is speed of light in that medium, will be in the denominator. So here you will see that on the basis of refractive index, also you will able to decide whether medium is rarer or medium is denser. So here if you see that V1 is the speed of light in medium 1 and V2 is considered as the speed of light in medium 2. Then they are trying to find the refractive index of the medium 2 with respect to 1. So that is denoted by n to 1. Means we are finding the refractive index of medium 2 with respect to medium 1. So speed of light in medium 1 will be kept in the numerator. Speed of light in medium 2 will be in the denominator. So that's why it is given here n21. Okay, so we are finding the refractive index of medium 2 with respect to medium 1. So speed of light in medium 1 divided by speed of light in medium 2. तो यहाँ पे क्या है V1 by V2. V1 क्या है स्पीड ऑफ लाइट इन मीडियम 1 और V2 क्या है स्पीड ऑफ लाइट इन मीडियम 2. Similarly, if you want to find refractive index किसका मीडियम 1 का with respect to medium 2, so that is denoted by n12 refractive index of medium 1 किसके respect में medium 2. So here the respect जिसका reference लेंगे that will be always in the numerator. So speed of light in medium 2 in the numerator, speed of light of medium 1 in the denominator. So that is V2 upon V1. So now here if you see that left side one diagram is here. So medium 1 क्या है air. So it will be the rarer medium. Medium 2 क्या है glass. So it will be the denser medium. Okay. So here again same thing. This R will be smaller than I. So for this medium, for particular ray of light, it's going to follow the Snell's law also. So sine I by sine R will be the constant. Okay. So now if medium 1 is going to be the vacuum or air, so there will be refractive index of the vacuum is almost 1, but for the air, we have little bit slight difference like 1.02 or something. So that is also can be taken as the 1. Okay. So when we are going to consider medium 1 as the vacuum or air, right? Okay, then the refractive index of medium 2 will be called as here absolute refractive index. So whenever if reference medium is what? Either vacuum or air, then when for which medium you are trying to find the refractive index, that will be called as the absolute refractive index. And speed of light will become what? 3 into 10 to the power 8 meter per seconds in case of vacuum. So now here then we are trying to find the refractive index of some medium. So reference is taken as the speed of light in the air. So that is in the numerator, and speed of light in that medium is the V. So finally C upon V. So in case of water, its refractive index is going to be 1.33. Okay. And in case of glass, it is 1.52. Okay, somewhere we might have discussion about this crown glass also. Okay, so now here, yes, this is the refractive index of the crown glass only, that is the 1.52. So here one table is given. Roughly you can go through this and by using repeatedly automatic you'll able to remember. Air का कितना है 1.003. Ice 1.31, water 1.33, alcohol 1.36, kerosene 1.44, and this benzene 1.50, crown glass 1.52, rock salt 1.54, and diamond is 2.42. So what we'll have finding from here that if refractive index is more, so that mediums are going to become more denser, optically denser. So and it is optically denser means that the speed of light in that medium will be less. Okay. So that like here suppose if you compare ruby and diamond. So in the diamond speed of light will be less in compared to ruby. Similarly, if you compare here medium is air and ice. So in the ice is the denser medium in compared to air. So speed of the light will be less. So kerosene having 1.44, so that are the optically denser. So if you try to compare water and kerosene, so kerosene is more denser in compared to water. So speed of light in the kerosene will be less in compared to water. Okay. But it is not related to mass density, it is the optical density. So here if you observe that kerosene is having high refractive index, means it is optically denser, but mass density of kerosene is less than the water. So this is not mass density, it is we are talking about optical density. So that is the things here. Okay. So finally here the finding from this is that it is when we are talking about rarer medium means it is the optically rare. So that is speed of light is the more in compared to denser medium. So denser medium means we are talking about the optically denser medium. So mass density is different and this optical density is the different. So speed of light will be higher in the rarer medium in compared to denser medium. So the ray of light traveling from rare medium to denser medium slows down and finally it is going to bend towards the normal. Whereas when it's going to travel from the denser to the rarer medium, then its speed is going to increase and it's going to move away from the normal. So these are the findings here from the refraction of the light and refraction in case of rectangular glass slab, and we have seen what is the refractive index. So you can practice this numerical, okay? In some other lecture, we'll try to solve all these questions, okay? And next lecture is going to be about this refraction of the spherical lens, okay? So here, any doubt is there, you can write in the comment box and like, share, subscribe so that all coming lectures you'll able to see. Thank you. Thank you.